what I'm really passionate about is making sure the things that we're building for multi-cluster and GKE land upstream in the open source, helping the team deliver some tools in SIG Multi-Cluster, which is part of upstream Kubernetes, right? And the purview of like SIG Multi-Cluster is to start to help build the primitives from multi-cluster tool chains across upstream Kubernetes, which we then use in the managed Kubernetes world.
Welcome back, fellow nerds. I'm your host, William, coming to you from the depths of Mount Doom, or let's just say Mount Yaml, where I'm going Lord of the Rings here. Where instead of the rings of power, we forge manifest of infrastructure. And with me is my companion co-host on this quest, Eyvonne Sharp, who, like Gandalf, guides others through the treacherous paths and perils of operationalizing multi-cluster Kubernetes and such. How are you doing?
Asked me which character I wanted to be, because to me the real hero of the story is Samwise Gamgee. So if you ever are going to pick a character for me, I want to be Sam. Anyway,
Well, I said Harry Potter, and I pivoted to Lord of the Rings like in a moment's notice because you said you hadn't read the Harry Potter books.
I know.
You see how fast I pivoted there.
I'm super culturally behind. Like, my husband and I just started watching Peaky Blinders. I watched Lost 5 or 6 years after it went off the air. So I get there eventually. I just have to have tons of evidence that it's worth my time. And
There is no evidence in Lost.
Well,
Yeah.
okay. That's
A
true.
little bit appropriately.
As in the time that you spent watching it would be
Lost. Yes. And that other voice that you hear is my friend, peer, and colleague, Nick Eberts. Nick, welcome.
Thanks for having me. Good to meet you, William.
If you don't know Nick, he is a product manager, GKE Fleets and Teams at Google Cloud. And Nick, why don't you tell us a little bit about who you are and what you do?
Yeah, I'm a human being. Allegedly. Yeah.
So you're not AI?
No.
It could be AI, and we would never know right now.
No, I have like the appropriate amount of phalanges and such. But yeah, so
I've been in this computer business for too long. Started with the Navy back in 2002. And I've had this weird progression. My degrees in geophysics, and somehow I'm still in computers. Whatever. I spent some time, moving up through the back end channels of what they call now engineering, platform engineering. Yeah, I was a sysadmin doing Linux stuff way back in the days. And then worked my way through a bunch of jobs. Now here I am at Google working as a product manager. The place that Eyvonne and I met was we used to be on the same team. And I'm sure everyone who's listening knows what team Eyvonne is on. She's on a special team. But yeah.
Yeah, that is absolutely right. The team that has 3 different names and several different iterations since then, but still doing, largely the same thing, helping customers adopt Google Cloud. That's what we do. So
It's
Nick,
really nice seeing sales and product people get along so nicely. I love it.
yeah,
we try. There's some what we would call healthy conflict and banter and camaraderie, and I think we need a bit of tension between sales and products to get to the right place. So we've all been there, and I suspect we've all been on both sides of that conversation.
Yeah. Well, I mean, but like just to take a moment to acknowledge that role, right? It's not just sales, it's being sort of tip of the spear, highest escalation point of sales engineering, right? And so I used to do that job, so I totally respect it. But like as a product manager, there is nothing more valuable to me than someone who does that job and talks to like hundreds of customers and uses the stuff. It's like an invaluable source of information and feedback.
It warms my heart to hear you say that, Nick.
True.
Yeah. So you mentioned the platform engineering words. I think I read I was reading like something I think it was Gartner that was saying it was like some high number, like 80 or 90% of software engineering orgs are going to have a team dedicated to platform engineering by like 2026 or 2027, which is pretty wild. So what is this platform engineering? Isn't it just DevOps? Like what is the difference?
So like, how far down the turtle are we going to go? Because like, what is DevOps? No, but so DevOps, I think we all know that it's a philosophy, right? It's a mode of operations. It's not a bunch of tools. Like, you can't buy a DevOps, probably my company would sell you one if you would want one. So, I think, like, for a minute, we've all been professionals in this industry for a while, right? So the arc of platform engineering, I think, starts with, I don't know, we were racking and stacking hardware and trying to serve the needs of the business in data centers that we own. And then the cloud came out and we said, oh, hey, we really shouldn't do that because then my job's not relevant. So we fought against it for a while. But then a bunch of people went out there, shadow IT, Amazon and Azure and Google. And when they did it, they kind of like made these teams of folks who understood the API surface of those clouds, right? So they can write a bunch of automation and they could do things like atomically. So the developer and this engineer, whatever you want to call them, DevOps engineer, work together to like quickly iterate and release software without having to deal with putting a ticket into the infrastructure team. Turns out that that's cool for a little while, but these enterprise organizations are huge. They have piles of different applications and teams. I mean, some of these companies we work with are literally like 15 companies. You know what I mean? I think there's a local company to me here in Georgia that actually has 5 CIOs, right? Because they're that big. And so then comes like the question of efficiency and governance and control. And so you take these people going fast, sort of inefficiently out on the edge. And you're like, okay, how do we allow them to keep on going fast, but get some consistency and some economies of scale? And I think that's what platform engineering is born out of. I could tell you one thing, like when we write these product docs in Google, one of the things that I like to start with is like, what isn't this thing? And this is the controversial bit. Platform engineering is not a UI.
It's not just an IDP.
And IDP is not define what does IDP mean?
Yeah, it's definitely not a UI or even like a service. It's a conglomeration of, I would say it's a conglomeration of different services that you're publishing for consumption by developers from some sort of centralized self-service platform. And you probably have a platform team.
Acronym IDP though. It's important here. I'd love to clear this here. It's not
developer platform.
It's internal developer platform. Yeah. And a UI is great. I think that if because what is a platform is a product, right? So what do you do when you build products? You interview your users, find out what they want, take those things, stack rank them based on priority, and then build them. So if a lot of your users want a UI and that would make their life better, then build it.
Yeah, you've got like, I want to clarify something. You sort of said like the DevOps was happening kind of on the edge, kind of the, hey, we're going fast. We have these automations. We're doing all these things, but you sort of alluded to, okay, it's kind of disjointed, but then like are you kind of saying the evolution of that in the right way in the context of a big organization is what platform engineering is? It's almost like a progression, taking those practices and guiding principles and making it consumable to like a large organization.
Yeah, that's great. You should market that. Maybe you could sell something. No, that's 100%. In fact, like internally, like we're writing a book, and like it's a large section of the book is just basically about like why it's important, and it's much more related to org charts and organizing human beings into pockets to deliver the right amount of value to each other than it is about like, again, tech. It's never really about tech directly, I think.
Well, and I think the place where we find ourselves, like for those of us who grew up when we were racking and stacking physical servers, and when you were, installing, like that's all of us, right? We are the elder millennial Gen X folks in tech. But you know, there were physical things in the physical world that helped us structure our organizations, right? Like we need a team that racks this server, puts in the rack screws, that
Yeah.
cables it to physical switches. And I think like the place where we find ourselves now is that the systems, they aren't physical. They don't exist in the physical world. And so we need a new way to map our organizational structures to the work. And it's not always as clear because there aren't physical things. They're all I mean, you go down far enough, there are physical things, but most of us that are operating in cloud aren't operating on physical things. So we need a new way to think about how we're going to structure our orgs and how we're going to structure our systems. And all of that is somewhat ephemeral because we can't put our hands on it. And so to me, platform engineering is about, okay, how do we develop those systems and structures and interaction surfaces for our people and the technology in a way that makes sense when there's nothing for me to physically look at to understand what it is. I feel like that's sort of the problem that we're trying to solve these days in the broader industry.
Yeah, for sure. And it's I think it's like this mechanism that we have to help promote DevOps principles in a bunch of smaller app teams, right? So like you build this platform. The reason you build it is because a lot of the times you want to give them a team self-service, right? You want to get out of their way, but you also don't want your business to end up in the paper because you got hacked because blah, 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 secret and whatever governance guardrail didn't get put up. So it's that.
Or HIPAA compliance or PCI or any of those. And that we have the added complication that a lot of those regulations and auditing processes were built and understood in an old framework that doesn't necessarily map to how we deploy technology today. So that's the other challenge. A colleague of mine shared this great, I believe it's a Churchill quote. He's like, first we make our buildings and then they make us. And I feel like that's where we are. Like we made this system of managing infrastructure and now it's shaped the next iteration, even though it doesn't exactly completely fit. So yeah, fun.
I almost feel like this. So like this. I don't know. I'm curious to get your thoughts here, Nick. But it seems like this shifts the outskirts of the responsibility from all these teams back to this centralized platform team, essentially. Like the responsibility of managing infrastructure complexities lies with the platform team, so that the devs, they can just focus on their building their applications and such. And with that being said, it almost seems like a drop-in replacement for like I don't want to say enterprise architecture, but kind of like a new wave of enterprise architecture type thing. Because usually enterprise architecture was like decoupled from the boots on the ground. Like they came up with these, they're in the ivory tower and they're just writing these things to shape how the business is going to run technology. And maybe these things are adhered to, maybe not. Maybe stuff was never updated. Maybe they're on the ball, maybe they're not. But platform team seems like this, they take that responsibility of the architecture and sort of marry that with the execution and the consumption as well.
Yeah, I mean, from my field days, field engineering, whatever, I mean, that was what enterprise architecture was turning into. And so like platform engineering is certainly older than the word itself, right? We all acknowledge that we've probably been engineering platforms for our entire computer life. But like when I would go into these companies, usually the job title of the person who's trying to figure out how to build the thing that they're going to share with everyone was an enterprise architect, and maybe still is. But I see the main flaw in enterprise architecture is too much talking, too much writing, not enough doing, right? So I hope that platform engineering gets those enterprise architects to start making their hands get dirty again and building. Because the platform itself that you're building should also adhere to the same principles that you expect the teams that are using your platform. You should be able to build and, I mean, move fast, but obviously not quite as fast because it's much more risky. But you should be able to iterate and improve the platform, right? And you need actual human beings to do that. And I still don't understand quite the value of the person that's just writing a doc and hasn't touched the code in years. I think that there's value there, so I'm sorry for all you that do that for a living, but I just don't relate to it.
Yeah, I mean, especially if you have your hands in the tech, like if you have a direct impact on the hands that are in the technology, you really need to have done or actively work with those technologies, or else mileage is going to vary greatly.
Well, and in order to be able to do that effectively and not have your own grubby little hands in it, you have to be a phenomenal listener. Um, and and be willing to hear people who have experiences that you don't have, and that's incredibly difficult for all of us. And actually, it's just much easier for you to sit down and figure the thing out than to try and suss it out from different sources without that hands-on experience. So, yeah,
I mean,
I get
so
what you're saying, Nick.
one of my new overlords here, in the container runtimes org in Google is someone I've known for a while. Gabe Monroy. A lot of people in our space know him. And one of the greatest things about Gabe is, and I'm not just kissing his ass, I don't do that. But one of the greatest things about Gabe is that,
I didn't get that.
ooh, Siri, hush your mouth. One of the greatest things about Gabe is that, like, if he finds out that you're falling behind or something or need help, like he's in the pull request, he's in the repo looking at the code, like trying to help you out. And we're talking about someone who is, 2 steps down from Thomas Kirian, right? He's got honestly no business doing it, except for that he's got every business doing it, in my opinion. I mean, that's really cool. I appreciate that someone at that level still cares and understands what we're dealing with.
I love that. That's great.
Let's talk about some of the pieces that make up this platform that we're talking about. I mean, you are on the Cloud Runtime Cloud Runtimes team. Little alliteration there is getting me this morning.
Yeah.
Let's talk a little bit about that work that you do there. Now, one of the questions that you had in the notes is really, when we're talking about Kubernetes, how many clusters is too many? Can you ever have enough or too many? Do you ever have too many Kubernetes clusters?
Yeah. Yeah. So that's, I mean, at the root of it all is just managing infrastructure, and Kubernetes is, I think, I've been in the community for almost a decade now. I just have to say that I need to go back 5 years and see if I can find that job that was out there in the world that required 10 years of experience when Kubernetes was only 5 years old. I now can actually apply for that job. So let's go. But yeah, so Kubernetes is like a operating system or an API for infrastructure. It's super handy. But it's not exactly the abstraction you want to give a developer who's writing business logic, right? They don't want to understand and try to comprehend and reason about all those things. It turns out also that platform teams, to some degree, maybe their life can be easier if they have to understand less about all of the idiosyncrasies of Kubernetes and the VMs underneath it and the storage. Like, you want to know enough to get your job done, and you want to make sure you're not getting overcharged. But maybe you want to manage service, right? Maybe you don't want to have to update the control plane on your own or data plane. And so that's what GKE is. It's a managed service. But then it turns out that, like, a platform, I've yet to see a platform team build a platform of one cluster, right? You ultimately, you'll have, either you're going to have environments, you know what I mean? You don't want to ship your dev code in prod, although I think it's pretty cool if you can pull that off. Or you have like regional constraints or high availability needs where you want to have multiple sets of infrastructure in different regions for either bringing your application close to your end users or for fault tolerance. But you ultimately end up needing more than one cluster. And Kubernetes itself is not, its world ends with the cluster that it lives in. Like, that's it. It doesn't understand other clusters. We've tried kubefed, rest in peace. Like, we've tried a lot, and it's failed every time. And so my job is to try again. And so the things that I'm working on are trying to stitch together multiple clusters and treat them as one. But the approach that we're taking is not to create a meta resource that represents both as much as to create an abstraction that allows you to treat both clusters as the same thing. Right? So if I'm able to...
The answer is always another layer of abstraction. It's always the answer.
Yeah, but like, okay, I know y'all are networking nerds, or at least I know for sure Eyvonne is, but one of the most challenging things with multiple clusters is how do I get like my pod in cluster 1 to be aware of a pod in cluster 2 in another region, right? If you make the networking discoverable across both, then you've all of a sudden now increased the availability of and the accessibility of that pod.
You're bringing me back some PTSD here. So like my first introduction to GKE, like you really like, I just got like a blast of information I totally forgot about. But so like we had a professional services engagement with Google. I mean, it's must have been, hold on, it was like 7 or 8 years. Yeah, like
We're a
7 or 8
very
years ago.
different place now. I'm just going to say that before I tell your story.
Sheesh. I can't believe it's just crazy it's been that long. But anyway, like I'd worked with like EKS, AKS from AWS and Azure respectively. And I can honestly say GKE at that time was quite a different experience. And in a lot of positive ways, really. So we started with cloud identity. You know, we had it tied to like our unique, like a DNS namespace for like integrating with all the Active Directory stuff. And then we had our, we went on and did like the folder and project hierarchy, the identity and access management stuff, the good old networking, the Kubernetes, and then all the logging, monitoring, stack driver stuff. But one thing that Google provided at the time with guidance on with the Kubernetes stuff with GKE was really helpful, and actually how we went back and optimized other Kubernetes environments and other clouds at the time. But it was not overcomplicating what we deployed versus what our needs were at the time. And what I mean by that is like we had a multi-tiered structure that balanced like the risk and efficiency and such. And like at the very top, it was as simple as we had production and non-production cluster, allowing for like these very distinct configurations for how we separated risk and security. And then you went one layer down, like layer 2 was like the business domains, like lines of business type stuff. And each domain got like I think the way that we had it canned out was like each business domain or line of business got one production and one non-production cluster. Mm-hmm. And then the third level was like the individual namespaces within each cluster for different products, or dare I say what we consider microservices. And this was a great feather in the cap of developer experience, really, as teams could work independently with their designated namespaces, minimizing blast radius, making security happy. But this was a big win for us because the way that we were doing it elsewhere is like developers were they had the control, and they were like, okay, each team gets a Kubernetes cluster. And it's like, hey, we have like hundreds of teams here. We've got, almost 1,000 applications. Like, how many Kubernetes clusters can one organization have? Come on. And doing it this way actually helped us.
Can you count?
Exactly. And that gets expensive because it's all compute, on the back end at the end of the day. So, yeah, it was I'd say it was a pretty positive experience. I'm sure it's a lot changed, or a lot has changed. And I guess my question is, so you're part of the product team that works directly on GKE, but GKE is big, right? So what specifically do you work on with GKE?
Yes, GKE, I think we have something like 25 PMs, more or less. So I am in core GKE, and I product manage fleets and teams. So fleets is you have more than one cluster solution. And then teams is sort of this abstraction as a service that we provide. So you were talking about, my developers in this previous slide that I had all had their own namespace. Teams is like namespace aggregation across multiple clusters as a service, right? So one of the tough problems that customers tend to have to think through, or platform teams have to think through, is like, how Are we going to do tenancy? Right? Are we going to do tenancy, single tenant, single cluster, single tenant, multi-cluster, multi-tenant, multi-cluster? And the answer is, at least what I've seen out in the wild, is that there's never one answer, right? Like if your organization is big enough, you have like a spectrum of tenancy. You've got some business critical app that's got dedicated clusters to it. And then you've got this like junk drawer cluster that's got all of these other tools and smaller services running in it. And then there's some like spectrum of other clusters in between. And so what I think is, like, even if you don't use teams, I think one good thing for a platform engineering team to think through is like, how do we not bury ourselves with tech debt by being too over opinionated on the tenancy model up front? And how do we build this to be adjustable over time based on the needs of the business, how we want to bin pack and unbin pack things over time? And so that's what Teams is out to do. It's just like this logical container of logical namespaces that then can get bound to clusters on demand. So today you want it bound to cluster A, it's there. You want to add cluster B, tomorrow you add it. You want to add more applications to cluster A and B, you then bind those teams to the cluster, and you sort of have that abstraction and flexibility.
Got it. What are the cases? So like we had the whole, I remember like before we even, I think, deployed a single cluster, you know, like the whole like big enterprise thing of, hey, we want to account for every possible scenario before we hit go and have an MVP or do anything. Like we just want to account for
having enterprise architecture again. Got it.
Yes, pretty much. Exactly. So they wanted to, we had this idea of, okay, well, what happens when we need new clusters? Like I remember we had a certain team that got stuck on this. We were stuck on this for like weeks. It was like, oh, but what happens when we need to create a new cluster? This is going to happen and that's going to have to happen. What this, what that? And I think if I remember correctly at the time, like it was like network exhaustion pretty much. Like, okay, we ran out of IPs, so we need a new cluster, I think. And then it was like node limit. And they were so concerned about the node limit, even though the node limit even at the time was like ridiculously high.
Yeah.
And then, I mean, I guess the last obvious one would be like isolation, like instances need isolation based on security, you know, based on, you know, however your business needs to run. Like maybe some clusters are in, you know, HIPAA sort of environments, and others are just production with no protected data or nothing really important as far as like customer impact. But I think those were the three things, if I remember: network stuff, node limit stuff, and then isolation. But are those like reasonable criteria still these days for needing a new cluster, or what does that look like in 2025?
I think it depends on where that cluster is being made. I can say proudly, if it's GKE, I do not think number of nodes is going to be an issue. Like we just released support for 65,000 nodes last year at KubeCon NA in Utah. So I don't think nodes is the thing. We do have, just to be real, like we built support for 65,000 nodes because we have demand. We have customers, like 3 of them that are using that many. But it's a very specific use case. But I think our job is to be able to build a product for our end users, the platform engineers, that removes the need for them to have to consider those low-level limits. Like I would prefer them to just focus on the compliance aspect of it, or like the business reason for them to have more than one cluster than an actual physical limitation of one. And over time, that's becoming more reasonable. Like one of the things that we've done on GKE is, I don't know how familiar you are with Kubernetes. I think you are. So I'm just going to say, like, we took etcd, right? And we're replacing it with Spanner, right? So we've removed the bottleneck of like a database running on literally in VMs in a control plane, and then use our own managed service that runs Google search and ads, all this stuff. So that greatly increases the request per second the API server can handle, right? So that request per second on the API server was the bottleneck. So we're making a new bottleneck now. Not exactly sure where it's going to be yet, but again, I think the idea is that we're trying to remove those limits from things you have to consider. Now, there's always other limits, right? IPs, IPAM is just, especially if you're a legacy company, it's just tough. We are rolling forward with IPv6, but like with the actual IPs allocated to the pods within the cluster, but then they have to like NAT everything so it understands the world outside. It's not easy. But that's the goal, is to continue to make the size irrelevant. My personal dream would be like, outside of business and governance rules, you have a cluster per region, right? Because they could be so big that it doesn't matter. And then I say that now, but also there's like the blast radius of change. So we need to do more work to make that real. But
Yeah.
one
IPv6 thing is huge. We'll get into that in a second, though.
Yeah. So
Continue.
I think I often, full disclosure, like ADHD, my brain's everywhere. So I'm probably the worst interview in the world. It's hard to keep me on track. But one of the things that I think will help you, like forget what I'm doing. What I would do if you were platform engineer, regardless of which cloud I'm using, even if I'm using on-prem, is I'm trying to build clusters fungibly. I'm trying to make them like just, it's the old pets and cattle analogy. I want them to be cattle. I want them to be replaceable. I want to add a cluster with the right label, have it come up to the right state, know what its job is, and do work. And I want to be able to remove a cluster when I need to. And if you do that, size doesn't matter anymore, because if you need more, you add more, right? Just like you're scaling out clusters like we used to scale out VMs, or like Kubernetes does under the covers.
Awesome. Yeah, the IPv6 thing, and you're absolutely right. The pets versus cattle thing, like I talked to so many folks in the network automation community that are still having challenges with this in large companies where they have names for individual servers. They're using automation like very limited, and it's the whole, hey, we still have pets in 2025. And I think that going up to the cloud does make it easier to do these things, though. You're not relying on as much iron, as it were. But even with, like you were saying, like IPv6 and the natting scenario, and that's just, you can I think what most companies are doing is they're embarking on this, at least on the consumer side, is they're dual stacking. They're doing as much as they can with, but even when you dual stack, like that introduces no matter what, it's complicated. Like you really want okay, we're just going to have greenfield with IPv6 only, but with, when everything has an IP address and has to talk with the whole system, one doesn't simply do that.
Well, we are still at a state in the industry where there is one key critical component somewhere in the data flow or somewhere in the in the path that doesn't support it, or there's some constraint that still is keeping us tethered to v4. And we've been talking about this for so long. I mean, I guess someday we will get there, but
Right.
yeah.
And then you have the implications that need to talk over TCP, and they need to know the outside of the Kubernetes service IP address, and then your whole network diagram just gets really fun. And that's every
house of cards.
Yeah.
Your house of V6 cards has just fallen. Yeah.
Speaking of your ADHD that you mentioned earlier, which I'm about to have and go off complete topic, but you mentioned Spanner earlier. Spanner's one of Google's many gazillion data products. Isn't that the one that automatically it has can do transactions globally? It has the multi-region automatic replication. Is it that one?
Yes.
It's SQL, right?
The way I like to describe Spanner is, first of all, Spanner is the data system that runs all of the underlying metadata for YouTube. So if you think about all that's required to make that work, it is a globally consistent database with incredible uptime. It's 5 nines. It's been a while since I've looked at the data sheets, but it is cap theorem defying because of what it does with the atomic clock. Like cap theorem is still real, right? I know Nick is shaking his head at me,
It does not.
but when you
It does not cap theorem. I'm sorry. Like I can't. I love.
say
We're
I say defying because it doesn't prove it wrong, but what it does it's some implemented some really clever atomic clock magic, that makes it appear to. Cap theorem is still real. Don't hear me say that cap theorem is not.
No. So like I mean, it's amazing. So I don't want to take away from it, right? It is amazing. And it's like the forethought to install and create a system that syncs atomic clocks across all of our data centers is what makes it possible. So all we're saying with Spanner is we're guaranteeing atomicity, right? At distance. That said, network partitions are still real, right? And so the way that, the risk of an actual outage is almost imperceivable. So we kind of say like it defeats cap theorem, but like the idea here is, I'm writing, it's a relational database system. It has ACID semantics, and you commit a change. We're just saying we're going to make sure that that change is committed and timestamped across all of the replicas, across all of the regions that are in that spanner shape. And then if one of those, there is a primary, this is why I say it's not really defeating. There is one primary at any given point in time, but we react and adjust, and you almost don't feel it because it's all on our network. It's super fast, and we guarantee the consistency, or at least guarantee the ordering. So in your app code, you have to then deal with conflicts, right? That's the part that people don't really talk about that often, but you still have to be able to, we can say, hey, there's a conflict, and then you decide whether you want the latest or the whichever version of that transaction commit. But it's amazing.
Yeah, it is amazing. I mean, because when you think about data, every cloud and thing is different. So you've got like availability zones that you have to worry about. And usually those are, of course, going to be synchronous replication across data sources. But then the moment you go multi-region in your whole infrastructure and application design, you're thinking about the, asynchronous replication, how that's going to work, active hosting across multiple regions or active standby. Like there's so many different things that go into the architecture, and data gravity is usually the challenge there. Because most applications are at least trying to go stateless as possible at this point, even though a lot of them do have a lot of state baked in inadvertently. But to take the complexity piece out of the database portion of that whole process seems like a really awesome win.
Yeah, I mean, just as a developer or a platform engineer, the fact that I could just provision this database system and not have to program how and when it fails over. I just pick a shape, right? And I understand like the trade-offs for that shape with cost and availability, and just go. As opposed to like back in the day, oh man, I have some war stories from my days at Microsoft of setting up. These folks would set up SQL databases in 2 different regions and then use like third-party technology to sync them.
Or log shipping or any of that stuff. It was brutal.
Yeah.
Been there, done that. Yeah.
Oh, jeez.
And you have to need that kind of scale and consistency to be able to use, it's a premium service, but it's also incredibly valuable, and it takes a huge amount of engineering overhead effort from your engineering design teams. You just don't have to think about it. And that's not something that we've been able to do for a very long time in this industry.
Y'all, there's so we have very brilliant engineers at Google, as there are everywhere, right? Some of them are young, fresh out of college, and they've only worked at Google for a couple of years. So their only real life experience with having to deal with consistency is Spanner, right? And sometimes I'm on calls with them like, do you know how good you have it? Do you know?
Like you
You
just
have a bless your heart moment. You have a bless your heart moment, don't you?
yes, not to be confused with bless your little heart moment, which my mother-in-law is super Southern, so I understand what that means.
Yeah. Yeah.
Um,
Yeah. It's like, oh, isn't that? Yeah,
yeah.
man. Yeah. But then you're starting that I walked to school uphill in the snow, both directions, kind of a conversation. So you're becoming that guy
Yeah, but in this analogy, like 80,
because of database consistency.
yeah, in this analogy, like 80 to 90% of the other folks that are in their position working for other companies are still walking uphill in the snow.
That's right. That's right.
Yeah. So what, like this whole, I have a lot of questions. Just, I know what the answer to most of these were back when I was doing this, but
Yeah.
things have changed. What typically, is it still the common thing to, for a large organization that's trying to modernize, or even like a medium-sized organization, it's got lots of applications? Are they still trying to profile, okay, like we have this set of applications, it's like a good fit that we want to modernize with GKE, and then we have some sort of process we go through in which the application's evaluated, it's broken apart, the dependency mapping, all these things. Okay, it's a good fit. Now we're going to migrate it. Is that kind of how the process works?
Yes, I think there's still a good bit of customers doing that. I do think that there's sort of been like, honestly, there's been like a little pause on cloud is the best thing recently. So a lot of people who are still in data centers are like empowered again to be like, no, we shouldn't change anything. So I don't know if there's as much of a effort across all these enterprise customers to migrate all the things. But yeah, I mean, there's still a triage. Like if you're a big company and you're just now starting, which I think most have already started, like you would pick the low-hanging stateless applications or something to experiment with. And then, then you have to go down the stack of complexity and work out how and when you want to migrate these more difficult applications. And then I just want to put this on wax. I'm still here to say that, like, if that application runs on .NET that's not supported on Linux, leave it on a VM. For the love of God, don't
Well, and
container.
that's what I was going to say. I think several years ago, there was a movement to just modernize all the things. Everything should always run in a container. That's the way of the future. This is the way everything's going to be. I think the more organizations have gotten in, first of all, I think some of them have learned how much they don't understand about their applications and how they run. And so if the application is natively meant to run in a container, if it's code that you're writing that you have access to that's going to be long-term strategically valuable for your business, it makes a lot of sense to replatform that onto Kubernetes. There are some applications though that do what you need them to do. There's not a whole lot of strategic value to modernize and update that particular application. And in those cases, I think what Nick is saying is like, leave that thing on a VM, but because you're always doing an opportunity cost calculation of what makes sense and where you need to put your effort. And so, I think if you think back to the very early days, there was a set of folks who just believed that serverless containers were going to be the only thing people used in the future. The world's just more complicated than that, right? And so the thing I would recommend for enterprise folks more than anything is know your application stack, understand what makes sense for it for your specific application stack. Because as much as we have opinions, you're going to know your stuff better than anybody else, including the Deloittes and the ENYs and the all of the consultants. And you need to understand that and then look for expertise, knowing your applications and your requirements to understand where it best should live. That would be my guidance.
But Eyvonne, I don't want to know these things. I just want a magic button.
Yeah, me
You must
too.
be an executive then.
Wait,
You're a VP now.
that's great. You put it better than I could. I think I've been disconnected a little bit from it, frankly, as now I'm so hyper focused on GKE and stuff. Like when I had that answer more eloquently stacked in my brain when I was dealing with those things every single day for 5-6 years. I will say, like, just taking it back to platform engineering for a second, I think another reason that the existence of this homegrown platform is a direct response to no company can build a platform that absorbs a significant amount of the workloads out there. Like, the best that we've ever had was Heroku. And there was a very, very specific style of applications you had to run to use Heroku. That was the best, right? It was. I still get happy when I think about like Heroku push or whatever, LF push, but it's like
that experience was second to none.
Yeah. But like, you can't do that for a legacy application. You certainly can't do that for, .NET 3.2, whatever web forms thing you have set up. So, the problem with the PaaS market, the companies are out there trying to build PaaS, and some of them are my buddies, like building WASM as a service, right? Is that it's only going to handle greenfield use cases for most of the time. And I don't have like a statistic anymore. I would love to know what it is, but I would go out on a limb and say probably 70% of the computers or the applications that are running out there are not greenfield. They're old, they're making money, and they're probably 30% of them are written in Cobalt or something. I don't know. So Kubernetes, though, what it did is it gives you like a higher lowest abstraction, I guess, right? So it can't do everything, but it could do a lot more than Heroku could. And so you could take this common infrastructure and then build different interfaces on top of it. Like, people are basically building their own Heroku style PaaS on top of Kubernetes, so they can have the new stuff, have the same security model, governance model, service discoverability as the old stuff. And that's the thing that Kubernetes brings that I think makes it so attractive. It's like, you could kind of put a lot here. Can't put everything here. Don't put Windows there. But you could put a lot.
I love the Windows comments. I don't even want to. It's a different.
Wait. Do you have a war story about Windows containers? Those are always fun.
I've been at a few fights. Like, we went through a period. It was probably about like 4 months of just like, there's just some things you don't do. If we're technologists and we have experience, there's certain things. It's kind of like stretching layer 2 yourself over homegrown services over like a DCI when you haven't set up infrastructure properly across both ends and haven't considered the distance between the data centers and all these things. And, the shared fate thing becomes pretty daggone terrible. It's like, hey, we know that this is just not a good idea at this point.
Yeah, you have shared fate, and it's really bad for everybody, is how that.
Yeah.
And
as in, the internet's down, and like, okay, we actually put one sensor on this side of the DCI for the firewall and the other sensor on the other side of the DCI in another data center because we were trying for high availability, like a hyperscaler. Sorry, how did we not think
this is all trauma.
Real quick.
This is all trauma.
For the user out there like me, what is DCI? I don't know. I probably
data center interconnect. Yeah, just yeah.
This is networking jargon. Okay, cool.
Sorry.
Yeah, that makes sense now.
Yeah, basically connecting two data centers and saying, hey, for high availability, we're going to put one thing in one data center and one thing in another and cross our fingers.
And then we're going to
until the internet goes down for the 5th time.
Google database across it, right? Yeah.
Yeah, we're gonna manage states across it and use layer 2 and all that fun stuff. Yes.
Yeah.
But that was William's analogy that you kind of went down the DCI rabbit hole there, but talking about Windows is what started that.
So Windows, here's the thing. So I did work at Microsoft for 5 years. And for a minute there, I was like tasked with trying to figure out how to help customers take their Windows workloads and put them on not even Kubernetes. It was Docker Swarm. But like, the dirty truth about most of the Windows containerization, and I'm talking about older Windows applications, not newer .NET Core and above that can do either Windows or Linux. So that's a whole nother conversation. But the older stuff, the stuff that needs IaaS, right? The root process of the container image is IaaS. So now where I had a IaaS farm before, let's say it was like five servers, and I was running 10 apps on it, but each server had one instance of IaaS running with those 10 apps running across it, sort of like containerization and bin packing. Now I have those same 5 clusters in a Kubernetes cluster, running Windows Server, and I have 10 instances of IaaS. So I'm doubling the processing requirement because the root of the container, the startup process for most of these apps was IaaS. So my question was always like, how is this? What are you getting out of this? It's not more efficient.
No.
Or do you just want to be cool? Because you're already not going to be.
But didn't we all get into this line of work to be cool? Wasn't that our?
I gotta give one notch. So one thing that I honestly can say that my only positive experience ever on a Windows machine was when they released Windows Subsystem for Linux 2.
Yeah.
And that made the experience of running containers locally, like the performance was actually good. If I'm doing it on my Mac with ARM, the performance of running Docker, because of the additional abstraction in the kernel, is not good. It's not fast. Doing it on Windows Subsystem for Linux 2 is actually very fast. I don't know how the mechanics of all that work and if it's really like, I don't know, but the experience is really good. Although I don't use Windows anymore, so I can't.
Yeah, I think it's like Hyper-V provisioned a Linux distro. And then they built like a really nice, it's great, to be honest. And a lot of our end users out there don't have the option to not use Windows, right? It's like a corporate mandate because of Active Directory and all these things. So good for them that they have WSL. I'm a little bit privileged. Actually, I'm a lot of bit privileged because just look at me. But like I use G Linux now. So I actually have a laptop with Google Linux installed on it. And that's what I develop on. And it's amazing. I don't have to like do any weird shenanigans. I just basically can run Linux processes, which containers are. Right.
I'm so jealous. If I could use a Windows or a Linux machine, I would run straight Debian for everything. That's I've been using Debian since like the late 90s. It's my OS of choice. I love it. I went to Ubuntu for like a hot second. I actually started off in Slackware originally. Landed in Debian at some point.
Slackware was my first distribution too. Yeah.
There you go.
Back in the day.
After using Slackware for a little bit, I'm like, do I really like this Linux stuff? And then I hit Debian, and Debian's just amazing. If I could run Debian on a machine for work, I would be a happy camper. Unfortunately, I can't and never have been able to. So it's back to the tricks. But at least now you can just ephemeral machine you can spin up in the cloud and run something, connect to it pretty easily and do what you need to do. But it's nice to have that local dev environment and that local experience with Linux.
Anyhow. Yeah. Hey, so my ADH brain is kicking in. I feel like, honestly, I could talk to y'all for like another 3 hours, but I'm sure we don't have that much time. There is one spot I guess I'd like to give.
Yeah.
So like we talked about a lot of great stuff. I'm working on like GKE, right? But what I'm really passionate about is making sure the things that we're building for multi-cluster and GKE land upstream in the open source. So like a lot of the work that I did last year, and when I say me, I mean, I'm product manager. I add value, little to no work that I did, helping the team deliver some tools in SIG Multi-Cluster, which is part of upstream Kubernetes, right? And the purview of like SIG Multi-Cluster is to start to help build the primitives from multi-cluster tool chains across upstream Kubernetes, which we then use in the managed Kubernetes world. So the one that we shipped right at Utah, so at KubeCon, or in that Kubernetes lifecycle version, was cluster inventory, right? So it turns out like all these tools that a lot of customers are using to manage multiple clusters, Argo CD, Flux, Fleets, they're basically just lists of clusters with metadata that allow you to kind of manage all of them, right? So if you want to use Argo CD and Fleets or Taverno or
whatever tool that you want to use, you now have to manage like 3 or 4 or 5 different cluster lists, right? So every time you add or remove a cluster, now you have to write glue code to make sure that that update is synced across all those lists. So what we decided to do upterm. Now you have me think about terminals. Upstream, yes, is to, make one list to rule them all. But at least this list is sort of neutral, right? You can make changes to this list. My stuff with Fleets of Teams will respect those changes, and like, so if you make a change on a member of the list, it'll actually reflect into whatever tool chain you're using with Fleets of Teams. I'm working with the Argo CD upstream team to build plugins so that it works there too. We've got multi-cluster queuing that's also going to key off this list. So the point here is that we have this centralized list that's hopefully going to make like the world easier for platform engineers, so they don't have to manage like 5, 6, 7, 8, 9, 10 or whatever. So the plug is, if you're interested, we would love you to join. So every SIG has a weekly or a bi-weekly meeting, right? We routinely get engineers from big companies like Google and Microsoft and VMware, and we're all working together. But we would love end users to come and join these meetings to validate what the heck we're building. So please, like, participate. Maybe there's like show notes or something I can give you all a link to look at. And it's open, right? So anybody can join. That's the beauty of Kubernetes and these SIGs.
Yeah.
Anybody.
And you mean, so SIG, you mean special interest group with the CNCF, right?
Yeah.
Awesome. Yeah, we will definitely link because I'm sure you said multi-cluster Kubernetes SIG, it was the
SIG
group.
Multi-Cluster. Yeah.
Okay, yeah, I'll find that group and I'll link everything in the show notes. That's a great idea. Yeah, the more you heard it, the more involvement, the better and more potential it has to be just amazing with your input out there.
Well, and I think, so one of the things that I learned, I'll say this, and we do need to wrap up, but one of the things that I learned after I was an enterprise network engineer and architect is that once I kind of crossed the chasm from the customer to the vendor side, I learned how important smart customer feedback is. And I realized I had a lot more value to my vendors than I understood at the time, because I was hands on keyboard using their stuff all the day, every day. I knew where the points of friction were, and being able to show up and have meaningful conversations with them about where I had problems, about what would improve the product, was incredibly valuable. And so don't sit there and say, I'm at maybe a Fortune 500 enterprise, a medium-sized enterprise, and we do a few cool things, but we're not super huge. Actually, you're in the sweet spot. So show up, make a contribution, talk about what your experience, because that is incredibly valuable.
Awesome. Well, so for all the kind folks out there, where can they find you, Nick? Aside from your, dancing videos on TikTok, where else online are you these days?
Dude, you've seen those? I thought I used a student in. Okay. Yeah. So I'm still on X, Twitter. I hate to call it X. I am on the Twitters.
I still call it Twitter.
Yeah.
Company.
I honestly would love for Twitter to be no more. So I'm also on Blue Sky, LinkedIn. SIG Multi-Cluster is like, if you actually want to talk to me like in real life as a human, join those things. But also I'd ask you, like, why would you want to talk to me? You could do better with your time. But if you have questions, or customers out there, end users of GKE, like I am happy to meet with anybody to take in that feedback. So just find me on any of those social platforms, and I shall respond. Also, I am way opinionated and loud on socials. It comes with a warning label, I guess.
And enter with caution, proceed with caution. You've done great on this talk, Nick, though. It's been wonderful.
Yeah. Really enjoy. Yeah, we went over an hour. We're over an hour right now. Believe it or
I
not.
know.
It's crazy.
It's good stuff.
Yeah. It's a good conversation when you don't realize how long it went. Yeah.
I feel like you need
Well,
to
thank you very
enter
much.
some
Like, I'm just like, you'll probably cut this part out, but you should like close us out with something about Lord of the Rings and YAML. Like just like have the bookend.
I need to come up with something clever. I actually think though that's a good idea.
What you're always thinking about the good guys. What about the bad guys? Like what is Sauron in this analogy? Is he like the underlying API that YAML's trying to organize? Is he a DDoS? What is he?
It could be both.
Yeah.
And you had many agents in many places. That's the thing. You throw in some VPs and some, part of the bureaucracy of the organization too, and you got
Imagine he's just like he's like a SQL database that has nodes in 10 different regions over the world. That's what he is.
Yes.
There's never actually a commit because they can never agree.
And then the world was darkness.
It's that script that syncs all these free Microsoft SQL databases that exist. Somebody wrote a homegrown script to sync all those. So they wouldn't have to pay for SQL and use the free, and that happens in the background. And
So that's the one sync that rules them all.
One sync. There we go. That's the